Okay, lesson 64, complex fractions and complex numbers. We're going to do the complex fractions video first, and we'll see how much Josephine helps, how quiet she is. She's very sad that her dad's so busy. Complex fractions, we're just dealing with problems where there's more than one fraction. There's a fraction in the numerator, a fraction in the denominator, and how to solve them. It's long and complicated. So keep your wits about you and best wishes. This is the first class practice one we have, where we have b over b plus 1 over z plus 2m. A few things to keep very straight is that we're adding here, because we're going to end up multiplying and things like that to cancel out denominators. But we need to remember when to add and when to multiply. First thing to tackle is what looks the hardest, this bottom part, this second part, and this bottom part first. So let's see if we can clear the fractions out of this whole business. I'm going to write it down here. 1 over, and I like a nice long line so I can work everything down here. 1 over z plus 2m. Now, how can we add 1 over z plus 2m? We need to make this guy with the z in the denominator as well. So we can do that by going times z over z. And this is 2mz over z. Now, there we multiplied, but now we have to add plus our 1 over z. See, I just copied this onto this side of the problem. Now, to do this, we just write this top up. So 2mz plus 1 over z. All right, see how that worked? Just like this had been 3/8 plus 1/8, and we get 4/8. We keep the z the same, the z. Now, all this is still over 1. So we need to clear this 1 out. I'm going to copy it again so we can clearly see where we are. 2mz plus 1 over z or z, whatever you want to call it. Now, to clear the fraction out of the bottom, we need to invert this guy so that we get a denominator of 1. So let's go. And here again, we're multiplying. See, it's confusing. When are we multiplying? When are we dividing? So we're going to multiply both of these guys by z over 2mz plus 1, z over 2mz plus 1. And 1 times this business, this times this equals 1. So we got rid of our fraction on the bottom, but we got our fraction on top. And that is z over 2mz plus 1. All right. So there we've solved this second part. So now I'm going to copy it down 1 and show that now we have b plus this answer here, z over 2mz plus 1. Now, how do we add b to this? b is over 1, of course, so we can go b over 1. So what we need to do is multiply this guy by this denominator, so we have like denominators, just like we did down here. So let's multiply this guy times our b. So I'm going to copy b over 1, and we're going to multiply by this guy. 2mz plus 1 over 2mz plus 1, and that equals 2mzb plus 1 times b is b over 2mz plus 1. All right, so there we've done this part, and then we need to add on our z. So plus z over 2mz plus 1. I feel like I'm writing out a lot of steps here, just hopefully so you can kind of see how it flows through. Now where we need to watch out again is I want to multiply, always want to multiply, but this is an addition sign in here. So here is our final answer. 2mzb plus b plus z over 2mz plus 1. All right, we did it. That is that. And I want to work this other one so that you get a little better feel for exactly how it works. I'm going to flip over my paper. I obviously ran out of room. And let's put that problem down. S over Z. I wish they didn't use Z's because they look so much like 2's. 3 over 5 plus 2s over z. Yikes. All right. So let's first of all clear the fraction out of this thing and make this just a fraction. First of all, add this. So 5 plus 2s over z. So what we're going to have to do is go to add, I'm just going to write it here. We can kind of remember this is our original problem. 5 plus 2s over z. Multiply this guy by z over z. Multiply by z over z. And we get 5z over z plus 2s over z, which equals, now again we have to make sure we add instead of multiplying, 5z plus 2s over z. All right, now this is still, all we did is we solved the denominator. We still have our 3 on top, with a big 3 up there. Let's make that guy big so we can tell what's going on. Okay, now let's invert this guy so we can get 1 on the bottom, so times z over 5z plus 2s times z over 5z plus 2s. Remember, this 3 is kind of 3 over 1 if we want to make it that way. So we end up with, finally, I'm going to copy it down here so we are there. 3 times z is 3z over 5z plus 2s, 5z plus 2s. I think this is a good z instead of an s. It looks like y on us. When there's x's and y's and all kinds of other letters, why do you have to choose these? I have no idea. Anyway, s, probably actually to make sloppy students make lots and lots of mistakes, and sloppy teachers too. Now we need to get a like denominator. So what we're going to do is we're going to multiply this guy. See, we can't add z onto this until we've got a like denominator. What we're going to do is multiply this business by this denominator and this business by this denominator. First of all, let's multiply this business by this denominator. I'm going to copy it over here. So we'll have s over z times 5z plus 2s. And this is over, we have to go same thing, 5z plus 2s. So now we took this denominator and we're multiplying it by both of these terms, this denominator by both these terms. And we're going to get 5z s plus 2s squared. Man, it's scary. And 5z squared plus 2zs. Oh, and I'm hating those z's and s's. Okay, and now let's multiply this guy. Let's multiply this guy by our z. So z and z. And I'll just write it right here. Z over z. And we get 3z squared. 3z squared over, and it's the same business as we've got there, 5z squared plus 2zs. So when we add this one, the second term, onto the first one, our denominator is the same, so I'm just going to copy 5. I'm going to copy this guy straight down. 5zs plus 2s squared over 5z squared plus 2zs. And this is going to equal down here our denominator we know is going to be the same, 5z squared plus 2zs over 3 times 5. Oh no, see, I started multiplying. We're not multiplying, we're just plain adding. So let's just copy 3z squared plus 5zs plus 2s squared. All right, that's that. That's our answer. We've solved 2 complex fractions. I hope you can follow and you'll be okay.